Okay, let's try this example. They've given us a potential energy diagram for the bonding that occurs between H and Cl in the hydrogen chloride molecule. They'd like us to go ahead and sketch in the curve that would exist for the HF molecule or the HF bonding process. So the first thing I always look at is bond order. I notice that in HCl and in HF, we're both talking about single bonds in each of those cases. Both have a bond order of 1. So any difference in strength and length is not coming from the bond order. So the second thing that I like to examine is the size of those atoms involved. We're talking about H to Cl versus H to F. The only difference is the chlorine versus the fluorine atoms. We know that chlorine is a bigger atom and a less electronegative atom than fluorine. Fluorine is the most electronegative atom of all, and it is very, very small. Being a small, very electronegative atom, that fluorine will hold on to those bonded valence electrons tighter than chlorine. We expect for the HF molecule that bond to be stronger. We're going to shift that minimum energy point downward on the potential energy diagram. And being a stronger bond between smaller atoms, the internuclear distance is going to be smaller. We're going to take that minimum energy point, not only shift it down to a lower energy state, a more stable state, but we're also going to go ahead and shift it to the left. If we then go ahead and sketch in the new curve that exists, we have our potential energy curve for the HF molecule. I hope that helps. Take care.